Algebra 1 Review Packet Part 4. You have the quadratic trinomial f of x is equal to x squared minus 10x plus 21. We're asked to first find the axis of symmetry. To do this, we use the formula x is equal to negative b divided by 2a. The a, b, and c values are going to all come from the equation. In front of x squared is your a value, the coefficient, which is a 1. The coefficient of the x to the first power term is negative 10. And then you have the constant, which is 21. So in the formula, we're going to take the b and make it negative. So it's going to be a negative 10 divided by 2 times 1. This is going to turn out to be 10 over 2, which is x is equal to 5. X is equal to 5 is your equation of the axis of symmetry. And now part B wants us to find the vertex. In order to do this, we're going to plug in that axis of symmetry x value into the equation. Y is going to be equal to x squared, so it's going to be 5 squared minus 10x. So it's 5 times x is 5, that's the x value, plus 21. $25 minus 50 plus 21. The y value is negative 4. Therefore, we know that the vertex is the turning point, so the x value is 5 and the y value of the vertex is negative 4. In our chart, which is the next step to build the table of values, we're going to leave 3 open spots, and then we're going to put our vertex on the third line. The fourth line. We're going to put an x of 5. We're going to rewrite all the steps of the computation. And the y value, or the output f of x, is negative 4. Then we're going to carefully choose our x values to have 3 of them below the vertex x value, which is a 5. So we're going to use a 4, 3, and a 2. We also want to have 3 above that x is 5. So we're going to use 6, 7, and 8. And we're going to make our substitutions and show our computations. So right here we're going to use x to be 2, so it's going to be 2 squared minus 10 times 2 plus 21. And then we're going to have 3 is x, so 3 squared minus 10 times 3 plus 21. Then we're going to have x is 4, 4 squared minus 10 times 4 plus 21. We already have accounted for our vertex. Then we're going to do 6 is x, so 6 squared minus 10 times 6 plus 21. Then we're going to take x is 7, 7 squared minus 10 times x, which is 7 plus 21. And finally x is 8, so 8 squared minus 8, 10 times x, which is 8 plus 21. And we're going to find out, using those computations, what those f of x or output values are. F of x is a fancy function notation way of saying y, or the output. What we could also do is use our calculator to help us. We know our equation. We can go to y equals and plug in that equation. X squared minus 10x plus 21. Just make sure you have the right window. So this sounds appropriate to use this window. We're ranging from x values at the minimum of negative 10 to the max, which is 10. We're counting by a scale of 1. Then we have our y min, which is negative 10, our y max, which is 10, and our y scale, which is 1. We could see what the graph should look like. That's what the graph should look like. We could go to second graph and find the table of values. So we're interested in when x is 2. We're going to scroll down. X is 2, our y is 5. We also could have computed that from taking 2 squared is 4 minus 10 times 2, which is minus 20. So 4 minus 20 is negative 16. And negative 16 plus 21 is 5. Then when we have an x of 3, our y value is 0. When x is 4, our y value is negative 3. When x is 5, we already know that our y value is negative 4, since that's our vertex. And then you're going to see the turning point. You're going to see the values start being symmetrical again. Back to negative 3 for the output. When x is 6, y is negative 3. When x is 7, you're going to see a y value of 0. When x is 8, you're going to see a y value of 5. Important to realize that when your output is 0, right here you have a root. So 3, 0 is one of the roots, or the solutions. Also, 7, 0 is another root, since the output is 0. We're going to go ahead and graph this on the grid. 2, 5, 2, 5, 3, 0. We're expecting it to be on the x-axis as an x-intercept since it's a root. And then we have 4, -3. And then we have 5, -4, which is your turning point, your vertex. I'm going to put a V to indicate that, or we could spell it out. X is 6, y is -3. X is 7, y is 0. You're seeing another x-intercept or a root. And we also have 8, 5. X is 8, up to 5 for the output. We're not going to connect this with a ruler or a straight edge because this is a parabola. It's going to be a U-shaped curve. I'm going to have to do that better. You want it to go continuously through the points and have a turn at the vertex. And you also want to put arrows because this does continue in both directions. That could have been a little bit of a better, smoother curve, but this is how it would behave. And then if we have to identify the roots, you would look to see where does that parabola hit the x-axis, and we've already identified it to be right here. So right here is a root, and that's 3, 0. And right here, which is 7, 0. These are your two solutions, x-intercepts, roots, zeros, of this parabola and quadratic equation.